it's felt like this is coming for a while. Like I almost feel like, the future is here. Like we're seeing this, we're sitting in a car with no driver. And so maybe you could kind of map out where we are in that kind of arc, the 5 levels of autonomy.
Yeah.
And also, where we still have left to go.
Yeah, certainly. We are in level 4 right now. So fully autonomous, as you can see, nobody in the front seat, no expectation of a human to take over. And, in level 2 and 3, it's really, really crucial to communicate the expectations to the driver. Because it's very easy that during a normal situation, the driver feels, the car is kind of driving well, so I can, pick up a book and start reading. No, that's serious. And there is an expectation to take over. So we are in that level 4 with a certain scope. So right now, if we were to begin heavily snowing in SF, which it has, believe it or not, last season there was a little bit of snow, we wouldn't operate.
We couldn't.
But level 5 is truly defined as anywhere, anytime.
Right. I mean, and even the idea of autonomy, people kind of view in this binary way, right? Like the whole idea of levels kind of puts that into perspective. Like level 2 is like lane sensing, automatic braking.
Right.
Is level 3 where basically what we're doing now, but there would be a human in the front, or how would you define level 3?
I would say a vast difference even between level 3 and level 4. Huge. It's almost like difference between driving and flying, I would say. It's massive difference because this concept still that within seconds you need to take over versus now we can have this conversation.
Yeah,
you can look
we're not doing anything.
Right? That would be challenging, right? But the assurance level you need to get to for level 4 is just a universe different, I would say. Okay,
so tell me a little bit more about the barriers along the way to level 4. What would you say was it the technology, the regulation, some combination? Are there major factors that have really delayed us?
The largest challenge I would say was largely, I would call it technology, but I mean 2 different things. One is building the driver itself that can drive under these conditions and having the high grade of performance, but also measuring that is pretty hard. This smooth sort of early stage drive under very tight constraints is now relatively, with today's technology, not terribly hard to build. But to be able to do that at the scale 24/7, busy intersections at slow speed, but also high speed intersections of Phoenix. So in Phoenix, for example, the streets are wider, so you don't deal with these narrow situations. But the driving speed is 45, people are sometimes going 60 on that. That means you got to see a lot further. So very different sets of challenges, very diverse ones. And the technology, and it really required the full stack, right? We build the hardware, we build the software, because if you built just the software and waited for somebody else to deliver the hardware, the speed of learning, the speed of iteration that was necessary to build something like this was so steep that it was not feasible. So we had to build the lasers, the cameras, the radars, and the software on top.
Let's talk about safety, right? I mean, that is like the foundational piece of whether we can get these cars on the road.
Right.
How would you say, between the regulators, the technologists like yourself who are building this, and then the consumers, the people, the riders, how do each of them view this like concept of safety? How are you designing the product with that in mind?
The analytical and quantitative version of safety, you can say, the nature of collisions you have, the probability of entering into a certain collision under certain circumstances, a lot of complications in there. There's the element of risky behavior. You may have gotten lucky that you didn't get into a collision, but you undertook risky behavior. And third and finally, do you make the person feel safe? So, we could be braking hard anytime we sense a risk. Or we
wouldn't feel very safe.
Exactly, you wouldn't feel very safe. And I think, and then the fourth layer I would add on top of that is, just because you figured out how to drive smoothly, meeting the expectations of a rider, you shouldn't falsely promise the true analytical safety either. So for example, designing an algorithm whereby you drive smooth on a street could be easy, but you shouldn't overpromise that you can detect a pedestrian jumping out of a car. That takes real, heavy engineering that consumer may begin believing that, just because it can drive smoothly, it can probably protect me from that. And I think being truthful about your capabilities is really, really important.
What does the data say, though? Can you kind of ground us in, there is a certain number of crashes that humans engage with every single year, and then where the technology is at relative to that.
I'll give you just two examples from many safety methodologies we employ. East Valley of Phoenix. We have been operating for a while. There, one thing we did is we took every fatal crash that had occurred and re-simulated and showed that Waymo could avoid that.
Okay.
That was one, very specific data set. What we also did is we were the first company ever to cross 1 million fully autonomous miles like this one. Nobody in the front seat. So there's no debate about what the car could have done. It was real miles. In that, we published our full crash stats.
Okay.
And there was not a single collision with injury in
Really?
1 million miles.
Not a single one?
Not a single one.
Okay.
And only 2 of them would, meet the standards of reportability called CISS. So this element of safety, it's not just about when it's driving, but it's about caring about safety every second.